Hi, welcome back to my channel. Right now, I'm going to create this kind of the electronic enclosure. As you can see here, we have two parts, which is the bottom plate and also the top cover, which is all of these two plates. We are going to use the screw cap using the countersunk screw. Okay. So, and we have holes here and also the fan holes over there. Are we going to create that feature and also the mounting here? Okay, for that. Okay, and now we are also going to use the feature which is the sheet metal feature, and we are going to apply the sheet metal rules on this particular enclosure. Okay, so let's get started. Okay, in order to use the sheet metal feature in the Fusion, you must to set up sheet metal rules, which is right now I'm going to use the aluminum and with the 1.2 millimeter of thickness, and then set for the bend radius to round, the corner radius for two bend intersection, choose the trim to bend option. Okay, save it. And then first create the component which is the sheet metal and give the name as a bottom plate. Okay, choose the appropriate aluminum as the sheet metal rule we just previously set up. Create a sketch in the top plane and use the rectangle with the center option 150 and 85 as a height. Okay, use the flange to make it the sheet metal plate, and the operation will be the new body. Okay, the thickness side you can choose within the one side or the side two, up and down, and also the midpoint. But in this case, I will use the side up as a option. Create a flange in the back of the plate, and then just drag the arrow key to the appropriate length, and also you can rotate the angle of the bend. Okay, in this case I will use 90 degrees, and this is the option which is the bend position. We can choose in the inside, outside, adjacent, or tangent. Basically this one is to control the position of our bend, and I will choose inside, and then make the flange again in the front position with the 15, and right now I will choose the edge option as the offset edge, which is I don't want to make a flange in the all of the edges but in the part of the edges, so I just can drag the option, and also we can put the fill of the offset, how much the offset, and then the angle you can choose whether the bend radius is okay. Choose the check the length which is 15 for the flange, and also we are going to the create another side of the flange on the other side, and using the two offset as well, 2 millimeter from the edge, and then we can choose the option of the reference from the very end of the this plate, and then just drag offset distance, and we will fill with the same amount of value from the previous one. Okay, just check 15 millimeter of length. Now we are going to add the fillet, round fillet on the sharp edges. So we're going to use the fillet and then choose the appropriate edge. Okay, with the value of 5 millimeter, you just use the shift key to make the multi-selection of the edges. You now create a sketch on the bottom plate and use the slot command to create a slot and control the size of the slot and also control the position with the constraint. Okay, change the appropriate radius and also the length of the center distance of the slot as well as the distance from the center point of the bottom plate. Okay, finish sketch. And then we're going to use the common extrude command to cut it, but we use the two object and then pick the vertex within the bend radius. So it will show the result as the okay, and then use the flange, drag it to the appropriate length. Okay, so we use the option with adjacent to put it at the same or flush with the bottom plate since this one has a feature which is mounting for this particular enclosure. So we have to put it flush to the bottom plate. Add a fillet with the value radius. Okay, yeah, 7.5 millimeter for the radius. Okay, and then hit OK. Okay, and then create a sketch which represent the holes from the small flange both of it. Use the horizontal constraint to keep it at the same horizontal distance and also the dimension of the position of this hole. After the center point has been settled, then use the hole command to create the hole. At first, we don't know how large is the hole. So right now I'm going to use a 6 millimeter as the diameter, but we can change it later on if we need it. Okay, I think the bottom plate has done. Okay, let me check. Oh, so we still need to add the holes on the hinge like that. Yeah, okay, put it in the center. So I will use the same diameter. Okay, just save the file. I will use the name electronic enclosure. Okay, and then now go to the top level assembly and then create a new part using the same sheet metal component, and the name is a top cover, and make sure the sheet metal rule is the same as the previous one, although we also can have the different rule for the different part, but in this case I will use the same. So create a sketch to the at the center midpoint between the plate, and then use the uh, project command to capture the position of the bottom plate. Okay, that one, and also this one, and just make it the construction as the line type. Okay, and now we are going to use the line command to create the base shape of the top cover, and then I will use the that dot as a reference from the bottom cover. And since this one has a plate, I have a thickness, so I will use the 1.2 as the same thickness as my sheet metal rule. Then finish the sketch and use the same command, which is flames, and choose the symmetric plane and just extrude with the 75 value, so both have the same length. Okay, I will use the side tool in order to make it flush from the top position, and also flush made for the with the bottom plate. Then I will use the planes again to create the down position of the planes. Okay, in this case I don't know how much the height, so I just put in the casing value. And then use the inside option for the bend position option. Okay, right now I think I need to adjust the height of this particular pen. So let me use this 27.4.5 as the temporary distance, and I will make a measurement. Okay, put the fillet at the sharp edges. and give the 3 millimeter as a value. Okay, over there, and as well as the other side of this sharp edges over there. Okay, so let me give the measurement of the distance uh, from to see the how much the gap. Okay, so I think I'm going to use the same gap as a flat thickness, so I will have minus 0.3. So that particular gap will be 1 millimeter from the, yeah, 1 millimeter. Okay. Okay, perfect. Now I'm going to add flanges. Okay, with the 10 millimeter height of the flanges. Okay, at the flanges as well at the bottom part of the top cover, but I don't want to use the full length of these flanges. So I will use the two offset as my offset option, and I will use the value which is it will flush with the previous flanges. So I think 18.3. Okay, here as well. Okay, 18.3. Okay, good. Okay, looks okay to me. Now I'm going to use the unfold feature. This command is basically to create the unfolded for the particular pen. And after we create the unfolded shape, so we can create a sketch, which is represent for the opening for my electronic cable to go through inside this enclosure, whatever within the inside of this enclosure. And I will put the dimension appropriately. Okay, because we use the unfolded view, so we can easily create the dimension as this plate was unfolded and create the distance, which is we can use the edge of the side planes as the reference for our distance. Okay, and then also create the slot for the side hole, and use the dimension appropriately, as you can see at the screen here. As the sketch is finished, then I use the extrude command to create the holes or create a cut to this particular plate. Okay, and then I still need the sketch to create to recreate the holes on the side slot over there. Okay, perfect. Okay, so I also can use the pattern command to create this feature, or I patterning this feature to the horizontal direction. Okay, just put the symmetric option for the direction type and use the 11 as a number of instances and 50 as a distance. Okay, that's all. And as you can see, if we already done to create this unfolded, so we have to refold the face to back to the original state of the sheet metal here. Okay, as you can see, we succeed. Okay, okay. Then I will add the flanges at the opening here. This later on I will put the decal on those particular plate or flange over there and give the information, and as well as another flange on the left side and also and the at the right side. Yeah, I think the value is correct. Okay. Okay, now add a couple of flanges for the mounting leg. Okay. Yeah, we'll use 15 as the distance. Okay. So I also want to put the round fillet. Just carefully to pick the select the correct edges, and you can use a zoom to easily pick the edges. Okay. I think I will use 7.5 or 8 probably. Yeah, I think, yeah, okay. Okay, and then add the holes on that particular like mounting over there. Okay, so I will check the inside as well as the outside. Okay, now I'm going to create the fan holes. So I need to create a sketch. Yeah, for this sketch, just follow the dimension in the screen here, and also for the position. Yeah, as the sketch is finished, so use the sketch pattern and select all the arc uh, arc slot. Okay, so select all the arc slot over there as an object, and then the center point of the circle. Use the number of instances is 4. Okay, and then just add the circle on the four sides of the rectangle, so it will represent the holes for the mounting of this fan. Yeah, the sketch is done, and then just use the extrude command to cut the holes with the fan hose shape into this particular top cover. Okay, like so. Nice. Yeah, I forgot to put a hole on that particular mounting, like mounting over there. So I will use the 6 millimeter of the hole and just position it appropriately in this the particular center point of this uh, fillet. Okay, yeah, make sure the left side and then the right side is the same position. So I just checking. So that one is the there, and the other side would be should be the same position. Let me check it first. Yeah, I think it's for that other side, that other point. Okay. Yeah, I think it's okay. Okay, so you can see here, I will project the hole over there into the sketch, which is I previously create the sketch at the side. Okay, so I just want to make sure that my holes it will at the same center point, center position from the previous one or from the bottom plate. I will use the countersink holes type, which is the clearance hole, and I will use M5. I think it's too large. M4 is still too large. I think I will use M3 in this case. Okay, I will use M3 for this case. Yeah, it's just quite small there. Okay, yeah, never mind. Okay, so on the other side, I will also use the same size of the screw. So when you design a product, I suggest that you will use the same or a standard size of the screw. So in order to shorten the bill of material uh, type, so you don't have to purchase a lot of type of the screw. Okay. Okay. So let me check the shape. Okay. Let me check it first. Okay. That's okay. Yeah, we'll use the point as well to create the holes to have the connection between the top cover and the bottom cover with this particular hole. Okay, yeah, just create and sketch all those tiny points as a reference for our holes later on. Yeah, the sketch is finished, and then use the whole command and the same value of the previous one. Okay, over there. Use the same, and please make sure that the object to cut is both of the bottom plate as well as the top cover. Okay, just multi-select using the shift key. Okay, and then hit OK. Yeah, just checking. Okay, okay, let me check for the top assembly. And you also can choose the appearance. So I will use the anodized aluminum. Okay, just click and drag your favorite color into this particular part over here. Oh, I think I have to realign the flanges over there. Yeah, the flanges is not flush with the ground. So let me search it again. Yeah, over there, and then I will use edit feature, and I will change the option to the adjacent. So make sure it's flush with the ground floor. Yeah, okay. Yeah, that's the advantage of the parametric modeling. So while we design, and then if we miss something or make a mistake, we can easily go back to the history, go back to the feature and edit it. Okay. Now I'm going to create the decal is represent with some kind of like a sticker within our 3D model. So you can create whatever you like as a image. So for example, I will create that particle information, and this will be useful for the your product appearance. Okay, I will put it appropriately and scale it as well. And I will uncheck the chain faces because it's just one flank. I think I don't need to create the chain faces. Okay, yeah, it's perfect. Okay, yeah, I think mostly the design is done, and I will put a screw over there. I will put the screw. I will load it or choose it from the McMaster car hardware component. Okay, just follow this step to put it the particular screw and make it at the appropriate shape and dimension and the size, of course. Okay. Yeah, as the hardware component is selected and downloaded from the McMaster card, so it will put it at the 000 or the origin point of your file, and you just use move command. And in this case, I will use the align command. Okay, I will use the align command to put it in place. Okay, over there. Yeah, perfect. And then later I will copy and paste the particular screws in order to put it at this particular position. But usually I also use the rename object because sometimes the McMaster card have the very long naming for their component. So the drawback when you use the part list later on in the drawing, so it will consume a lot of space over there. So usually I will just rename to the appropriate information as I need it. Okay, now we finish attaching all the screws, and sometimes we want to look inside in the particular case, so you can change your view to the perspective view. So within this perspective view, when you hover your mouse and also you align your mouse using your 3D orbit, you can easily look inside of your part. That's one advantage how we can use or utilize the perspective view from our product. Okay, just change the appropriate dimension. Previously, I'll use the 6 millimeter as the holes over there. So right now, I will change it to the appropriate nuts, which is later now I will put the nuts over there. Okay, let me use the capture position, and I will search for the nuts. Okay, screw nuts here. Uh, Select the nuts and then choose the metric and appropriate the same size as the screw. And I will use the, I think, is it well? Hmm, I don't think it's fit for this particular case. Let me look for another nut. Uh, I don't want to make our design is too complex, so I will use the inserted nut, I think. Yeah, I think there's a press fit over there. I will utilize this press fits feature. So it's basically because the case is from the aluminum and then the nuts it will be going to press fit inside those aluminum. Okay, so that's the idea. So we don't have to necessarily uh, put a lot of effort while assembling this enclosure in the real life because that nut is will be already in place inside our screw using the press fit. So that's a particular like a gear shape, which is that gear particular gear shape will go through inside of this our holes. And firstly, I will measure the diameter of this gear, and then I will adjust my holes appropriately to match up with these holes. Okay, I will make a 4.5, so it left me some of the aluminum to put it inside of this plate. Okay, so again, I will use a line to this particular nut here and then put it inside there. So since I'll at the perspective view, so I can look inside through my product and easily assemble the nut at the appropriate position. Okay, and then just copy paste all those nuts and then put it using align command to the appropriate position. Okay, just capture the position. Okay, like the previously I did using the align and then just put the all those nuts at the appropriate position. Okay. As the assembler finished, then use the inspection to cut section and see how our bolt connection here is appropriately at the correct position. Yeah, I think it's a good and perfect position over there, as well as the uh, top position over there. Okay. Okay. Yeah, I think. Oh yeah, I forgot one more thing, which is the most important of the sheet metal, which is we can create a flat pattern. So to documenting this sheet metal, we have to create a flat pattern. Just click flat pattern and then pick the stationary face, and boom, they will Fusion will automatically create our flat pattern. Okay, over there. And but this flat pattern is associated with this part. So when you want to create multiple, like so, yeah, you just select the top cover and then click the flat pattern and then choose the stationary face and then yeah, just like that, the Fusion will create our flat patterns. These flat patterns we have to documenting this shape and dimension later on in the our drawing. Okay. Yeah, I think we are now at the end of this tutorial. So thank you for watching and don't forget to subscribe if you think my channel is a good advantage for your learning. Thank you and bye bye.